Welcome to Mrs. Fairbanks's math class. Today we are going to be graphing sine as well as doing some transformations. So when we graph sine, I like to start with the unit circle. With the unit circle, it's called the unit circle because our radius is 1. If we divide that in half and we're looking at radians, we're at pi over 4. Then some other important pieces are pi over 6 and pi over 3. We've worked with the unit circle so that we know the values of these points. And because it is sine with a radius of 1, we know that the sine is the opposite, which would be our height. So we are looking at our y values when we're graphing sine. If we were going to go ahead and plot all of these points all the way around the unit circle, all the way to 2 pi, we would have to graph 16 points. But I'm going to show you how to graph sine using 5 key points. Then we will talk about its properties. So with this, I'm going to do my coordinate plane. I'm essentially going to unroll the unit circle. The sign of 0 is 0. Let's put some radians on here. So this would be pi, 2 pi, pi over 2, and 3 pi over 2. Those represent my quadrantal angles all the way around. So sine of 0 is 0. When I go all the way around, sine of 2 pi is 0. Sine of pi is also 0. We're going to have an amplitude of 1, so that means I'm up 1 and down at negative 1. The sine of pi over 2 is at the top of my circle. That is the point 0, 1. So I'm up here at my maximum of pi over 2 comma 1, and then at 3 pi over 2, I'm at my minimum. I'm going to connect those 5 key points with a smooth curve. Please remember that this is just one cycle. This would continue on, it would continue backwards. For our properties, I have a max at the point when x is pi over 2 and y is 1. I have a minimum at 3 pi over 2 and negative 1. My domain, using interval notation, we just said that it would be going on forever in both directions, so x can be all real numbers, so that would be negative infinity to positive infinity. My range is going to be from negative 1 to positive 1, both included, so I am going to do a hard bracket on both. So that's how you can graph sine using your 5 key points. So now we're going to put in our letters A, B, C, and D. We're going to use our transformations to graph sine and see the effect that each letter has on that. So we're going to start with y equals 3 sine x. My A value is 3, which means my amplitude is 3. So from my midline, I would be going up 3 and down 3. That's the only thing that we're changing in this graph. So I'm going to keep my spacing the same as I just did with pi over 2, pi, 3 pi over 2, and 2 pi. My period here is still 2 pi. When I think about graphing this, I'm going to think about it in fourths. So when we are on our unit circle, we've got our first quadrant, second quadrant, third quadrant, fourth quadrant, which is also in the fourths. So the sine of 0 is still 0. So if I plug in sine of 0 times 3, it's still 0. So I still have a point at 0, 0. The sine of pi is still 0, even when you multiply it by 3, as well as 2 pi. Now I'm up 1, 2, 3, and down 3. So at halfway in between the pi, I'm going to go up pi over 2, put a point for my maximum. Halfway in between the second half, and I'm going to have my minimum. I'm going to connect those, and I like to draw them in 4 pieces so I get that nice curve piece. And this is one where my amplitude was 3, which means it's vertically stretched. It was vertically stretched in the direction of y. If we want to check this, and we want to check this point pi over 2 comma 3, I can plug that in. So y equals 3 sine of pi over 2. Well, the sine of pi over 2 is 1, and 1 times 3 is, in fact, 3. So that one does work. So when you change your a value, you're changing your amplitude. Remember, your amplitude is the distance between your midline and your maximum, and your midline and your minimum. Okay, so we just graphed y equals 3 sine x. We saw the effect of a changing our amplitude. Now, if you notice with the second equation, I've added a plus 2. So we're going to investigate what the d does to our graph. And just like all of our other family of functions, that last term is going to move it vertically up or down. So this sine graph is now going to be shifted up 2. So I'm going to draw my coordinate plane. And instead of having my midline at the axis, I'm going to be up at 2. I'm going to draw a dotted line just so that my graph can have its middle at all the correct spots. Please keep in mind, though, that that is not an asymptote. So we've got our pi over 2, pi, 3 pi over 2, and 2 pi. Now with my new middle at 2 and an amplitude of 3, that puts me up at 5. It also puts me down at -1. So my graph is going to be in between there. I would suggest also dotting those in so that your max and min can be all even and you wouldn't have changing bumps along the way. So my original sine graph, the sine of 0 is 0, but now I'm going to move it up 2. If I plug in 0, the sine of 0 is 0, times 3 is 0 plus 2. So I know I'm at the right spot there. The same thing is going to be true for pi and 2 pi. When I cut this half in half, I'm at pi over 2 with an amplitude of 3, which is going to put me up at 5. At my minimum, I'm at 3 pi over 2 at -1. And we're going to have our nice sine curve. So this is a sine graph that has an amplitude of 3, and it's been shifted up 2. If I were to write the range, it would be between -1 and 5. So we've looked at the effects of A and D on their graph.